So this session is going to be recorded. Good morning, all of you. Good morning, grade 7 students. In this presentation, we are going to talk about our chapter, respiration. So respiration includes, can we live on Mars? We said that it depends. So respiration includes two of the most important respiratory gases. They are oxygen and carbon dioxide. So anatomy of the respiratory system includes the nose, the mouth, pharynx, larynx, trachea, the lungs, which is the most important organ in the respiratory system, the bronchus, bronchioles, and finally the alveoli. So the pathway of the air includes the nose, pharynx, larynx, the trachea, the bronchus, the bronchioles, and finally it moves to the alveoli. Breathing is the actual intake of air. Breathing consists of two main phases: inhalation, whenever we inhale; exhalation, whenever we remove air outside the body. So inhalation is the process of taking air inside our body. This is inhalation. Exhalation, we are releasing air outside the body. The movement of the thoracic cage, during inhalation, if you see here, thoracic cage will increase, will be raised. Why? During exhalation, it will lowered. State of the lungs will be full of air, so they are going to be inflated. Why? During exhalation, they'll be deflated. They will get rid of the air inside them. Thoracic cage, during inhalation, look to my thoracic cage, will increase, will raise, and during exhalation, will decrease. Pathway of the air, during inhalation, air is going to enter from outside to inside. Why? During exhalation, from inside to outside. Grasshopper, you have to know that during inhalation, the abdomen in the grasshopper is lowered, meaning that it's lowered down as seen in this figure, while during exhalation, it is raised. You have to know that the respiratory organ in all insect is the trachea. That's why they have a special type of respiration, which is called tracheal respiration. The air enters through the spiracle to the trachea and then move to the tracheal. You have to know about the animals that live on land. We have lungs. In mammals, we have trachea. In insects, so both of them, they live on land. So now let's move to the aquatic life form. The fish says, it's my turn. You have to tell me about my respiratory movement. So you have to know that respiratory movement of the fish includes the operculum and the mouth. So during inhalation, the mouth is open. Why? Because the water is going to enter through the mouth, and the operculum is closed as seen in this figure. Why? During exhalation, the mouth is going to be closed and the operculum will open. So during inhalation and exhalation, what can you say about the respiratory organs in the fish? It's the mouth? Sure not. It's the operculum? Sure not. It's the gills. The gills, they are respiratory organ. They are present on the skin. So whenever we are talking about respiratory gas exchange, we are talking about air gets in for animals living on land like the insects and mammals, and the air gets out during exhalation. Water gets in for the animals that live in water, like the fish, for example, and the water gets out during the exhalation. So whenever you say gets in, water in, we are talking about inhalation. N, air in, water in, inhalation. Out, outside the body, it's exhalation. So what the animal respires, what happened to the air and the water around? What do they absorb and what do they release? All of you know that respiratory gas exchange is the passage of respiratory gases between air or water and the respiratory organ. This is a very important note for your quiz for the next week. So pay attention to this note. I'm going to ask you a question. What will happen to the lime water if we place a fish inside lime water? You have to know that this lime water will become turbid. Why? Because we have release of CO2. So lime water becomes turbid in the presence of carbon dioxide. This is a very important note for our quiz. So pay attention to some notes for our quiz. So which gases are respiratory gases? We did this experiment. Aim of this experiment is to study the respiratory gases in fish, respiratory gas exchange. So we have this table showing the variation of the quantity of oxygen, carbon dioxide, and the nitrogen the oxygen, it decreases from 7 to 5.6. The carbon dioxide, it increases from 3 to 4.1, and nitrogen remains the same. We have to transform the table into a graph. Always, always, always. The one that's found above the table will be in the x-axis in the graph, and those will be in the y-axis. So this one is decreasing, it represents the oxygen. The one is increasing, carbon dioxide, and the one that remains constant is the nitrogen. Don't forget to give the title. Title of the graph is variation graph showing the variation of the oxygen, carbon dioxide, and nitrogen gases in water in milliliter. You have to mention the unit as a function of time in minutes. So interpret. You have to remember that. Interpret, it's analyze plus indication. So at time 0, the quantities of oxygen, carbon dioxide, and nitrogen, they were 7, 3, and 19 respectively. What the meaning of respectively? Oxygen is 7, carbon dioxide is 3, and nitrogen gas it's 19. So at the time passes, the quantity of oxygen gas decreases to reach the minimum level, the minimum value, meaning that the lowest value, minimum value 5.6 milliliter, when at time 6 minutes. What does this indicate? This indicates that the fish is consuming oxygen gas. You have to not use is using, it's consuming oxygen gas. So oxygen is a respiratory gas. For example, the graph, as time passes for carbon dioxide, the quantity of carbon dioxide, it increases to reach the minimum value, the maximum, meaning that the highest value, 4.1 milliliter at the time 6 minutes at the end of the experiment. What the meaning of this? The carbon dioxide is increasing. So this means that the fish is releasing carbon dioxide. This question, maybe I'm going to ask you, what will happen to the lime water in the presence of fish? You have to say the lime water becomes turbid. You have to know that oxygen gas is the oxygen, the gas consumed, while carbon dioxide is the gas is released. So oxygen and carbon dioxide, they are respiratory gases. While for nitrogen, as time passes from 0 to 6 minutes, the quantity of nitrogen, it remains the same. It remains constant at 19 milliliter. What does this mean? This indicates that the fish is neither consumes nor absorbs. So meaning that the nitrogen is not absorbed nor released. It remains the same. It remains constant. So nitrogen is not a respiratory gas. So what would you deduce? The fish respires. The meaning of this, it inhales, it takes, it consumes oxygen, and it exhales, it releases carbon dioxide. So respiratory organ of mammals living on land, lungs. So you have to know that the lungs, they are rich in blood vessels. And if you remember, this is another note for our quiz, that the lungs, they are rich in blood vessels, meaning that they are highly vascularized. Remember this note. So why there are many blood vessels in the lungs? What happened to the air whenever it increases? So what is responsible for transportation of oxygen and carbon dioxide in our body? It's the blood. That's why the lungs are rich in blood vessels. So the blood reaching the lungs is going to be poor in oxygen and rich in carbon dioxide. But the air is the opposite. The air in the lungs is going to be rich, highly rich, contain high amount of oxygen and very poor in carbon dioxide. So what happens to the blood when it enters the lungs? Let's compare this table. This table is showing the variation in the quantity of oxygen and carbon dioxide in milliliter for each 100 milliliter of blood. And for example, this one is 15 milliliter for each 100 milliliter of blood. And the blood entering and the blood leaving. This one is showing the quantity of oxygen in milliliter and blood entering and blood leaving. And this column is showing the quantity of carbon dioxide in milliliter and blood entering and blood leaving. If I ask you to compare the quantity of oxygen in blood entering and blood leaving, you have to say the quantity of oxygen and blood entering the lungs is 15 milliliter for each 100 milliliter of blood, which is, you have to say, less than or greater than 15 and 20. Sure, 15 is less than the quantity of oxygen in the blood leaving the lungs, which is 20 milliliter for each 100 milliliter of blood. So here you have to pay attention. You are comparing oxygen with oxygen, not oxygen with carbon dioxide. Oxygen with oxygen in the blood entering and the blood leaving. Quantity of carbon dioxide blood entering the lungs is 53 milliliter for each 100 milliliter of blood, which is less than or greater than 49. Sure, it's greater than the quantity of carbon dioxide in the blood leaving the lungs, which is 49 milliliter for each 100 milliliter. So this is the lungs. The blood entering is poor in oxygen, while the blood leaving is rich. The blood takes oxygen from the lungs. What is the respiratory organ? And some animals living on land, lungs, like humans and rabbits and frogs. A beta shape of frogs, they are amphibians. So frogs on land, they use lungs for respiration. So on land, they have a type of respiration, it's called pulmonary respiration. While in water, we will see later on. I'm talking about frogs in specific. So animals living on land, they have lungs as a respiratory organ. We call them animals having pulmonary respiration. Why? We have some animals that live on land and they don't have lungs as the respiratory organs. What do we call them? They are called insects. Insects, what do they have? They have trachea. This is the respiratory organ. So what do we call their respiration type? It's called tracheal respiration. While those having the lungs, it's called pulmonary respiration. So let's continue, please, about the gas exchange. Diffuses. What the meaning of diffuses, if you remember? Diffuses mean that moving from a medium of high amount, high value, to a medium of low amount or low value. So oxygen gas diffuses from the trachea that's rich in oxygen to the organs that are poor in oxygen. Here, if you notice that the oxygen diffuser from trachea is rich in oxygen to the organs that are poor. So the oxygen gas moves from a medium that contains high amount of oxygen to a medium that contains low amount of oxygen. This is the meaning of diffusion. Why? Carbon dioxide, the opposite. It diffuses from organs that are rich in carbon dioxide to the trachea that is poor in carbon dioxide. So diffusion meaning that escaping from a medium that's rich in a substance to a medium that's not rich. For example, we are in grade 7. I have in my grade, for example, 100 students. Okay? I have in grade 7, 100 students. One of the students in grade 7, he wants to move away. He wants to move to grade 8. They have only 10 students. So he moved from a medium of high concentration to a medium of low concentration. Or if you say, for example, we are playing football, 100 students, they are playing football. And 10 students, they are playing basketball. So let's say Gabriel decides to move to play basketball because it's less condensed. There are no more students. 10 students versus 100. So 100 students, a very concentrated, high amount. So we're going to move to the basketball, low amount. So the meaning of diffusion. Here, Gabriel diffuses from football toward basketball. So here, oxygen gas diffuses from trachea that is rich in oxygen to the organs that contain low amount of oxygen. And carbon dioxide, the opposite. It diffuses from the organs that contain high amount of carbon dioxide to the trachea that contain low amount of carbon dioxide. And earthworms, we have something special here. First, let's make a quick revision and some notes. First, we have lungs as respiratory organ. The animals that have lungs as the respiratory organs, we call them, they have pulmonary respiration. Insects, they have trachea as a respiratory organ. So we call them, they have animals that have tracheal respiration. Earthworms, they are special. They have the skin. Their skin is a respiratory organ. So earthworm, they have cutaneous respiration because the skin is a respiratory organ. Another note for our quiz. For example, I have an earthworm. I covered her skin by a wax, let's say. I covered her skin by a wax. So there's no more small opening to respire through the skin. What will happen for the earthworm? The earthworm will die. It will die. Why? Because it can't respire. Because I covered all its skin. So this is another note for our quiz. So what is the respiratory organ of fish living in water? Sure, the gills. The gills, there are present 4 gills on each side. Water enters the mouth. Step number 1. Water is rich in oxygen and is poor in carbon dioxide. Then water reaches the gills, where blood vessels they are poor in oxygen and they are rich in carbon dioxide. 3. Oxygen diffuses from water rich in oxygen to the blood gills. Where carbon dioxide diffuses from blood rich in carbon dioxide in gills to water. So as such, the water leaves the operculum, poor in oxygen, and they are rich in carbon dioxide. Under the water, as I said, frogs, they have special respiration underwater. They respire through their skin. So their skin becomes the respiratory organ. So what do we call them? They have cutaneous respiration. Where? Under the water. So under the water, they have cutaneous respiration. So as a note here, a special note for frogs or amphibians, the animals that live both on land and in water. On land, the frog, it has pulmonary respiration, while in water, it has cutaneous respiration. Moving to our book, activity 2, page 50. We talk about this respiration in air medium, pulmonary and cutaneous respiration. We have here the respiratory organs movement in the rapid and the pathway of the air. The air enters through the mouth, the nose, the lungs will be inflated during inhalation and deflated during exhalation. This is a rhythmic movement and it occurs periodically. It's a rhythmic movement that allows the entry and the exit of water. Here, let's compare the composition of oxygen and CO2 in blood entering and the blood leaving. Here, we're talking about oxygen, and here we're going to talk about the carbon dioxide. So oxygen, the quantity of oxygen gas in air entering is 21 in 100 milliliter, which is less than the quantity of oxygen in the air leaving the lungs, which is 16.2 milliliter in 100 milliliter. The quantity of carbon dioxide was 0.02 in the air entering the lungs. Why? 0.03, sorry, which is less than the quantity of carbon dioxide in the air leaving the lungs, which is 4.3 milliliter in 100 milliliter. You have to know that a note here that the frog is an amphibian. It lives in water and on land. Outside the water, it respires through the lungs, so it has respiratory movement, while under water, it has cutaneous respiration. It respires through the skin. Frog rises to the water to respire to get air. Lungs of a frog filled with air. This is the figure of a lung filled with air. So trachea form a network. This is the trachea, and these are the trachea, and these are the spiracles enter. The trachea form a network of branched tubes, small tubes. They are called the tracheals, in which the air circulates to reach the organs of the grasshopper. So when the lower part of the abdomen, as we said, is lowered, so air entered between the spiracles, this is called inhalation. When the lower part of the abdomen is raised, so the air comes out, this is called exhalation. If the spiracles are covered with wax, as I said for the earthworms, if the spiracles they are covered with wax, they are closed with wax, the grasshopper dies due to the lack of oxygen. So justify why inhalation permits the renewal of the gas. We said that it's rhythmic, it occurs continuously. So this one, inhalation and exhalation, they are rhythmic movements that allow the entry and the exit of the air in the lungs. This ensures the renewal of the air. The air is going to be renewed every time. Inhalation and exhalation. Okay, guys, let's move to the second part. Compare the amount of O2, which was 21 in the air entering. This one is analysis. Entering the lungs is part 2. So that the respiratory gases occurs at the level of the lungs, because the amount of oxygen, which was 21 in the air entering, decreased to about 16.2 in the air leaving. While that of CO2, it was 0.03 in the air entering, and it increased to 4.3 in the air leaving. So the lungs, there was absorption. We absorb O2 since the amount of O2 decreased, and we release CO2 since the amount of CO2 increased. So this is called respiratory exchange. Very important note, and you have to study this note. This is a very important note for our quiz. The characteristic that make the alveoli a good place. Why the alveoli are a good place for the gaseous exchange? we have two important characteristics for grade 7. We have a thin wall, it's very thin, and rich in blood vessels that I told you is called highly vascularized. This is an important note. Pay attention to this. Respiratory movements of the grasshopper, they are manifested by what? So respiratory movement of the grasshopper, how they are manifested. You have to know that the lower part of the abdomen is lowered and enters through the spiracles. We call this inhalation. When the lower part is raised, this is air comes out of the spiracles, and we call this exhalation. So the composition of the air entering and the blood leaving the trachea. Let's move to figure or the table H, composition of air entering and leaving the trachea. In the air entering, the oxygen was 21. The air leaving decreased to 5. And 0.03 for carbon dioxide, and it increases to 6. So here we have to talk about the composition. Compare, you have to say that the quantity of oxygen and the air entering the trachea was 21 milliliter in 100 millimeter, which is greater than that. Okay, comparison, greater than and less than. This is very important. If you didn't mention in the compare greater than or less than, meaning that you didn't do compare. You have to pay attention to this. Now, this composition of carbon dioxide, it was 0.03 in 100 milliliter. You can say per, this dash slash means per 100 milliliter or in 100 milliliter, which is smaller than, or you can say less than that in the air leaving. So the air is impoverished in oxygen, meaning that it's poor and enriched the CO2 at the level of the trachea. The pathway in the grasshopper, the inspired air will enter through the spiracles to the trachea and then to the organs. Part 6, they told you why the insects living in water regularly move to the surface of water. We answered this question the last time, because the insects that have trachea, that allow them to respire in aerial medium and not in water. Because of that, they move to the surface to respire. The trachea conducts directly the air toward the organs. Now, we're going to move to the respiration in the aquatic medium. Here, if you see here, figure A and B. A, the mouth is open and the operculum is closed. This is called inhalation. While here we have the mouth is closed in figure B and the operculum is open. Here we're talking about exhalation. Okay, so you have to pay attention to this. Gills, the organs of respiration for the fish. Here we have the gills. They have some gill filaments like these filaments. They are observed under the magnifier. The gills are formed of numerous filaments where the water circulates. The current is created by rhythmic. It occurs in a rhythmic manner. Let's see this table. This figure showing the gas with exchange of the gills of the fish. 170 liters of water circulates and the gills contain 170 liters. And imagine this, 170 liters, meaning that approximately 100 bottle that you drink a large bottle of water. The quantity of gas in water, oxygen was 0.7 and carbon dioxide is 0.03. While in the gas in water leaving, oxygen becomes 0.14. It decreases. Pay attention, 0.7 means that is 0.70. And oxygen is 0.14. So 0.7, sure, it's greater than 0.14. And 0.03, here is 0.04. It increases. So first part, explain why does the respiratory movement in the fish occur? How does this respiratory movement occur? It occurs when the mouth is open and the operculum is closed. We call it inhalation. When the mouth is closed and the operculum is open, we call it exhalation. What is the importance of this respiratory movement of the fish? It allows the renewal of the air. It allows entry and exit of the water, and it allows the renewal of the water. Pathway that followed by the water during respiration in the fish. The water enters through the mouth, then to the gills, and then to the operculum. Part 3, we're not going to draw and label a gill. Part 4, what are the characteristics that make a gill a good place for gas exchange? They are similar to those in the alveoli, but here we have numerous gill filaments. We have filaments, that's why it's a good place for exchange. and they are red in color. Why they are red? Because they are rich in blood vessels, meaning they are rich. The blood vessels means that they are highly vascularized. Number 5, justify why the color red color attributed to the gills. We answer this right now. The red color of the gills is due to the presence of high number of blood vessels. For 6a, interpret. What the meaning of interpret is analyze plus implication. So the quantity of oxygen, it was 0.07 in the water entering. It decreases. Whenever we talk about interpret, analyze, we don't have to say greater than or less than. Pay attention to this one. In the analyze, if we have values, I have to say it increases or it decreases. And compare, greater than or less than. In analyze or in interpret, you have to say it increases or decreases. So the quantity of oxygen and the water entering, it was 0.7%, which is less than this comparison. Here we want to interpret, meaning that analyze. The quantity of oxygen and the water entering, it was 0.7%, which decreases to 0.14% in the water leaving. And the quantity of carbon dioxide and the water entering, it was 0.03%, which increases to 0.4. So at the level of the gills, the water is poor in oxygen and is enriched in carbon dioxide. What can we conclude here? We have a change in the quantity of oxygen and carbon dioxide. The oxygen decreases, the carbon dioxide increases. So we can deduce here, we can conclude that the gas viscosity change occurs at the level of the gills and the fish. Okay, guys? So I hope everything is good, and I hope you enjoyed this session and you can watch this session again, study well, and pay attention to the